Hi there, folks. Today we're looking at the midterm review, just going through all these different things that we've gone through this year so far, and just reminding ourselves of how to do some of this stuff. So, diving right into it here, we're going to start with expressions, move our way into equations here. So, write an algebraic expression for the quotient of j and 8. And this is a pretty simple example of this. We've done others of these, but this is a jumping off point. So if you're looking at this going, oh, I need to review some of that terminology, that's a good thing. You go back and you look at things like, oh, quotient is division. So the quotient of j and 8 would be j divided by 8. Okay. Product would be multiplication. Sum would be addition. Difference would be subtraction, that kind of stuff. So go back and look at those kind of things, okay? If I look at the next one, following order of operations. Remember, for order of operations, I like to look at it this way. I do IRM-DOS. If you do PEM-DOS, that's okay. But we just work our way through. We say, okay, hey, we're going to do inclusion symbols like parentheses and absolute value and those kind of things first, the brackets and braces. Then we're going to do exponents and roots, then multiplication, division, then addition and subtraction. Remember, the reason I stack them is there is a tie here. These are tied, so the tiebreakers left to right. These are tied, the tiebreakers left to right. These are tied, the tiebreakers left to right. So if I look at this first one, inclusion symbols like parentheses, so I start inside the parentheses. So I'm going to do what's inside these parentheses first and these parentheses. So inside these parentheses, I add these up. That's a 32. Inside these parentheses, I do that subtraction. I get a 1. And now from here, I have multiplication and I have division. Those are tied, so I have to go left to right. All right. In this particular example, I have to do this multiplication first and then the division, because if there's a tie, I go left to right. So I do the multiplication first. So 4 times the 32. Is going to be a 128. And then divided by the 1 is still a 128. Okay? If I look at the next one, again, I start inside parentheses, but there's two sets here, all right, because they're inclusion symbols. These brackets are parentheses, and then these parentheses are also inclusion symbol. They're like parentheses. So they all act the same way, but they're inclusion symbol. It's broader than just parentheses. So inside the first set of inclusion symbols I see would be this. Well, I kind of hit the reset button. Once I'm inside here, once I'm looking in between these two values, this guy and this guy, I say, okay, let's go back to order of operations. I do inclusion symbols, and see, that tells me then to go into these innermost inclusion symbols. And then within those inclusion symbols, I see exponents and subtraction. I do the exponents first, okay? So I'm starting inside those innermost inclusion symbols. I do the exponents first. So that's a 25 and a 16. And then once again, I go back to those innermost parentheses, those innermost inclusion symbols, and I do the subtraction that's inside there, and that gives me a 9. And now I go back to inclusion symbols again, except I'm done with those innermost inclusion symbols. Now I'm looking at these inclusion symbols. I do what's in between these inclusion symbols next. And so again, within there, I still have to follow order of operations. So I have an exponent, I have division, I have addition. So I'm going to do the exponent next. Sorry, that's a 36. Next, inside those inclusion symbols, I do the division. Next, inside those inclusion symbols, I do the addition. And really, just like parentheses, when I don't see an operation written between that 13 and the bracket, it's multiplication. So that implies multiplication here. So that's a 169. Okay? But again, we're doing one step at a time, following order of operations. If I look at the next one gives me an expression with these variables. I've got u over z plus x times y to the second. And I'm just going to substitute in. Anytime I substitute in, it's always a good idea to use parentheses. So up here, I'm going to use parentheses around each of the things that I substitute in. Not that you always need these parentheses. Like with this 20 and this 10, the parentheses absolutely don't matter. Okay? But it saves me some mistakes down the road. Okay? And so here we go. I've got all this plugged in. I follow order of operations. I've got division. I've got addition, I've got multiplication, I've got an exponent. I'm going to do the exponent first. And again, I'll drop all those unnecessary parentheses. So here the multiplication gives me a 49. And now I have a decision between the division and the multiplication. I do the division first, and that gives me a 2. Over here, because there's an addition sign, I can do this multiplication. That would be my next step. So if I want to condense it a little bit here, and I mean, I could do this in separate steps, but if you just want to condense it, because I know that's the next step and I haven't written it down yet, we'll go ahead and do the multiplication here. And then last, I do the addition. Okay? If I look at something like this, it says, name the number sets to which 22 belongs. Remember, our number sets, if we're talking about the real numbers, our real numbers are broken into two big categories, the rational and the irrational numbers. And then the rational numbers are broken down into a bunch of little categories. We have the integers, the whole numbers, and the natural numbers or the counting numbers, okay? And so when you look at something like 22, all right, we're trying to determine, well, what's the smallest category that fits into, okay? The smallest category that this one fits into is the natural numbers, okay? But if it's a natural number, it's automatically a whole number. And if it's a whole number, it's automatically an integer. And if it's an integer, it's automatically a rational number. And if it's a rational number, of course, it's also a real number, because we've only dealt with real numbers here, okay? If we look at something like this guy, the square root of 42, well, that's a never-ending, never-repeating decimal, which makes it an irrational number, so the smallest category is an irrational number. But then, of course, it's still a real number as well, okay? For this one, we want to order this from least to greatest. And so what we want to do is we want to put this all in the same format. Instead of having roots and fractions and decimals, let's convert it all to the same format. The easiest format to convert to is the decimals. So just take a little bit of calculator time here. You plunge in the square root of 5, you get 2.24. That next one's already a decimal. The negative 5 over 3 becomes a negative 1.67. 0.7 is already good. And then I just punch in the square root of 2. And so once these are all written kind of in this decimal format, they're a lot easier to compare. So as I look through this thing, I'm going to start with the negatives. So the most negative of these numbers is the negative 1.67. So that is the smallest. So I'm going to write that one first. And again, I'm going to write it in its fraction form. I go back to the original, okay? So that one's done. Next is going to be the negative 0.1. So that one's done. And now I'm moving into the positives. As I look at these positive values, the smallest one is the 0.7. Next is the 1.41, which is actually the square root of 2. And then last, the biggest of these is the 2.24, which is the square root of 5. And that's it. Okay, now they're in order from least to greatest. And again, I'm able to do that by putting them all in the same format first. Okay? If I look at this one, it says, at the video store, you buy 2 CDs for $18.90 each, and a DVD for $20.50. Use mental math to find the total cost of the purchase. And so if you're looking at something like this, the whole idea here is kind of breaking this into pieces, all right? We could plug this into a calculator, that kind of thing, but we want to make sure we're exercising those mental math skills. If I wanted to take something like this, I want to do 18.90. I want to do times 2, right? Because I bought 2 of those. Well, break it into pieces. Do the dollars and the cents separately. If I had $18 twice, well, that would be $36. Okay? If I had 90 cents twice, that would be $1.80. Okay? And so together, we can see that this is $37.80. Okay? But then I also want to add that $20.50. And again, when you do that, the mental math approach is to look at the dollars and cents separately to say, hey, you know what? When I add those dollars together, that's $57. And when I add the change together, 80 cents plus 50 cents, well, that's $1.30. And so now as I continue to combine those, that's $58.30, okay? But that's, the big key to mental math and being able to do things in your head It's about breaking this down into pieces that make sense, okay? Same thing here. At the grocery store, you buy a carton of milk for $3.90, a loaf of bread for $1.95, and a bag of cookies for $3.05. Use mental math to figure out the cost here. And so as we're looking at this thing, there are two things that we want to do. One, we'll still break it down into pieces like we did before. But two, we want to use some of the properties to make this easier. So as I look at this, you're hopefully looking at this thing and, hey, you know, those second two numbers looks like they would add well together, okay? And so just keep in mind our commutative property, since this is all addition, I can do it in any order I want. So I can add these two first. And see, that's beneficial to me because the 95 cents and then the 5 cents give me an extra $1 here. Okay, so the change is $1. I have a 1 and a 3, so that's 4. So that's a total of $5. Okay. And see, that's easy to do because we're combining that change first, because we can see it works out nicely. And now from here, if I add those guys together, that's $8.90. Okay, so changing the order in which we do these things, if we're allowed, can sometimes be beneficial as well. Okay. If we look at these, just doing some mental math, solving these in our heads. Remember, when we have addition and, when we have positives and negatives, okay, when the signs are different, it's essentially subtraction. So if I have a 7 and a 5, when I subtract those, I get a 2, okay? So a negative 7 and a 5 is the same thing, except it's going to be a negative 2, okay, because the negative 7 is bigger than the 5. So you essentially do subtraction and then just keep the sign of the larger value, okay? Same thing here. When you look at these, they're both negative. Well, when the signs are the same, you just add them up. You say, hey, I have 6 negatives. Now I have 3 more negatives. That's a total of 9 negatives. So it's a negative 9. Okay. This one, same kind of thing. They're different signs. All right. The 6.1 is bigger than 1.7. So when I do this, I'm going to subtract, but then I'm going to keep the sign of the larger value. So I'm going to make this thing negative when it's all said and done. But essentially, I just do 6.1 minus the 1.7, which is a 4.4. But I just make it a negative 4.4. Okay. For this guy, remember when you're multiplying, you could multiply straight across, numerator times numerator, denominator times denominator. But when we're multiplying fractions, we're allowed to cross reduce. So here, I could cancel out the 10 and the 10. Oh, sorry, that marker's a little large there. Let me reduce the size. Here we go. Cancel out the 10 and the 10. Okay, it's essentially 10 divided by 10. That's what fractions are. They're division signs. So I'm multiplying by 10, but I'm also dividing by 10. Well, those cancel each other out. All right. And so what I'm left with here is I just have a 5 in the numerator and then a divided by 3 for the denominator. That's it. Okay. If I look at something like this guy, if I were to do something like 12 to the second power or negative 12 to the second power, I would get 144. So 1.2 is essentially the same thing, except I have to put this decimal now in the right spot. And since this had a 1 decimal place over, because it's 1.2 times 1.2, I count up those. So each of those had 1 decimal place. So I'm going to move 2 decimal places and put it here. Okay. If I look at something like this guy, you can just leave that plus or minus out front. You just take the square root of each of these individually. The square root of 100 is a 10. The square root of 49 is a 7. And that's it. Okay? If I look at this guy, this is my distributive property, even though it's written backwards from what we're used to. I'm just going to distribute that negative 1 to the binomial. And so negative 1 times 4 is a negative 4. Negative 1 times negative c is a positive c. And that's it. If I look at this guy, we're combining like terms, so we're looking for like terms here, same variable with the same exponent. So when I look at this, these guys are like terms because they are the same, they are identical in terms of the variable portion. And then all 3 of the rest of these are like terms as well. Okay? And so if I do the 1.2 plus the 1.7 plus the 2.5, that's a 4.2. And then I just keep the variable part the same, m squared. If I do the n values here, it's a 6.5 minus a 4, which is a 2.5, and then minus another 1n, which is a 1.5. So 1.5. And again, it just stays as an n. Okay? If we look at something like this guy, it says write as a sum or difference. Essentially, is telling us to use our distributive property. It's saying get rid of the multiplication and division, so we only have addition and subtraction here. And so we just divide each of these. So this is our distributive property. So here, I just do the 3 divided by 9, or the 3x divided by 9. And then separately, I do the 2 divided by 9. And then it's just reducing these things. This is a 1/3 x minus a 2/9. And so even though there's still division technically because of the fractions, I'm still writing this strictly as subtraction. It's just subtraction with fractions in it. Instead of having multiplication, subtraction, and division, I've simplified this in a way that I've reduced the number of operations. Okay, but again, it's just my distributive property for division. Okay, this one is my distributive property for multiplication. And keep in mind, when you don't see a number there, it's a 1. So I'm distributing a -1 this time. So that's going to give me a positive 10p minus 4r. Okay, so just using our distributive property both from the perspective of division and from the perspective of multiplication. If I look at these guys, okay, solving equations. Remember, when we're solving equations, we're simply working backwards through order of operations. We're undoing the operations as we go. And the other thing that we do is we look for ways that we can simplify before we do that. And so if I look at this first one, there's a way that I can simplify before I start undoing operations. I see my x's in different spots, so I want to get the x's together. Okay, I can't have x on both sides, so I need to get rid of one of those x's. So I always get rid of the smaller one. I always get rid of the something like the 2x here. And I get rid of the 2x by subtracting 2x. Whatever I do to one side, I have to do to the other side. And so that leaves me with 1 equals, that's a 2x minus 5. Now I can work backwards through order of operations. I undo addition and subtraction, then I undo multiplication and division. So in this one, I'm going to undo that subtraction first by adding a 5 to each side. And now I'm going to undo that multiplication by dividing each side. And that's it. Okay? If I look at the next one, again, I want to solve this. And one of the easier ways to do this, I could just go right to following order of operations, but most of us are going to feel comfortable simplifying first. So I'm going to simplify by doing my distributive property, and then I'll start solving. So I'm not even solving yet, I'm just simplifying. So I simplify by doing the distributive property. Now I can solve by undoing operations. So I'm going to add the 8 to each side, so I undo that subtraction first. And now I undo that multiplication. And that's it. Okay? If I look at the next one, I have subtraction, I have division. Normally we would undo subtraction first, but there's something here that we can't see. We know it's there, all right, but we don't see it. It's not written. There are invisible parentheses. See, that division, that divided by 3, is happening to this entire numerator, which means that entire numerator is technically in parentheses. So in this scenario, if that numerator is in parentheses, if it really means this, then that means I have the choice of undoing the division first or undoing inclusion symbols, all right? And if we're working backwards to order of operations, we have to undo division before we undo what's in the parentheses, okay? So I undo the division by multiplying each side by 3 here. And now I undo that subtraction by adding 2. All right. If I look at the next one, once again, I'm working backwards through order of operations. There's nothing to simplify here. So I just start working backwards through order of operations. I undo subtraction by doing addition. And then from here, the fractions can be a little bit tricky. But again, if we remember what a fraction is, a fraction bar is a division sign. All right, and so when I see a fraction, it's just 2 operations happening at the same time. So 6 over 7, that's just times 6 divided by 7. I'm just going to undo each of those one at a time, okay? And I'll typically undo the division first. So there's a divided by 7 there. So I'm going to multiply each side by 7, okay? And then once again, the divided by 7 and the times 7, these cancel each other out, okay? That's kind of the point here. So I'm left with a 6x. Over here, the 7 times 15 is a 105. And now I'm going to divide each side, okay? And so again, a fraction is just two things happen at the same time, all right? So you undo each of those one at a time, and when I divide this guy, I get 17.5. That's it. If I look at the next one, something like this guy, when I see a lot of fractions all over the place, and I could have done this with the previous example, when I see lots of fractions, I kind of want to get rid of those at once, all right? I want to get rid of those right away because it's really tough to deal with all these fractions. And yeah, I could subtract like that 2/3 from each side, but it's a lot easier to eliminate the fraction first. And remember, since fractions are just division signs or special division signs, I can always get rid of fractions by multiplying through by the right number. And it's always by multiplying through by the common denominator. So if I look at the 6, the 3, and the 18, the common denominator between all of those is an 18. So I'm going to multiply each side by an 18. And again, over here, I have to distribute that, all right? So if I do 18 times that first guy is f divided by 6. So just think of it this way. I'm doing times 18 and divided by 6. Well, I can just kind of use those together and say 18 divided by 6 is a 3. So I'm left with a 3f. Okay. The next one, same kind of thing. That's times 2 divided by 3. Well, 18 divided by 3 is a 6. And then 6 times 2 is a 12. Okay. And that's how we approach mental math with these fractions. Over on the other side, the divided by 18 and the times 18 just cancel each other out, and I'm left with a 7, okay? And again, you could do things like, when I did the 18 times the 2/3, you could do 18 times 2 and say that's a 36, and then divided by 3 is a 12, okay? But I'm choosing to do the division first just to keep the number smaller. But look at the equation I end up with. That is a really easy equation to solve, and it's brought to us by the fact that we multiplied through and got rid of the fractions. So clearing those fractions is really important because it makes life a lot easier for us moving forward. So now I can undo operations here. I'm going to subtract the 12 from each side. And I'm going to divide by the 3. And I'm just going to leave this as a fraction, -5/3, because it's easier to leave that way. Sometimes it's appropriate to write it as decimal. The last one I did as decimal. This one I'm going to leave as a fraction, okay? And always follow the directions if one says to leave it one way or another, okay? If I look at this one, it says Stephen wants to buy a $565 bicycle. Stephen has no money saved, but will be able to deposit $30 into a savings account when he receives his paycheck each Friday. However, before Stephen can buy the bike, he must give his sister $65 that he owes. How many weeks will Stephen need to deposit money into the savings account in order to buy the bike and pay back his sister, of course, okay? Pay back your debts first. And so if I look at this thing, he's just saving $30 per week. So I'm going to call it W. So it's $30 times the number of weeks, right? That's how much he puts into this savings account, all right? And we essentially want to build up that account, all right? But keep in mind, we're going to have to take a little bit of that money away. We have to take $65 away because we owe that, Stephen owes that to his sister, okay? And so if he's putting away $30 per week, but we take away 65, we now want to know in total, when is that going to equal the 565? Okay, when is that going to equal the amount that he needs to buy this bicycle? Okay, and so once again, I'm just setting up this equation, and now I can solve this thing. Okay, so working backwards sort of operations, I'm going to add that 65 to each side. It gives me 630. And now I'm going to divide each side. So I get 21. Okay? So 21 weeks is what it's going to take. Okay? And again, we had to do that minus 65 because that's what we had to take away from what he was saving to pay back his sister. Okay? If we look at this one, John and 2 friends are going out for pizza for lunch. They split 1 pizza and 3 large drinks. The pizza costs $12. They spend a total of $16.95. We want to know how much did each drink cost. Okay, so we have to think about this. So John and 2 friends. So how many drinks, first of all, they're going to be buying? Okay, so 3 drinks. So I'm going to say 3 times D for the drinks, or the price of the drinks. We don't know what that is. Plus the money they spent on the pizza, which is $12. And that should equal the total, which was $16.95. Okay, so again, 3 times the number of drinks because they bought 3 drinks, plus the pizza here. And so once again, I'm just working backwards sort of operations. So here I'm going to subtract the 12 from each side. So it's going to be $4.95. And then I'm going to divide each side by the 3. And you can use a calculator for this one. That's 165. So each drink costs $1.65. Okay? And again, we're just thinking about the situation and working backwards to that answer. That's what solving equations is. It's working backwards through a process to get back to what you were looking for. Okay? If I look at this one, a copy center offers its customers 2 different pricing plans for the black and white photocopies of 8.5-inch by 11-inch pages. Customers can either pay 8 cents per page or pay $7.50 for a discount card that lowers the cost to 5 cents per page. Write and solve an equation to find the number of photocopies for which the cost of each plan is the same. Okay? And so if we think about this for a second, we want to set these equal to each other. So let's think about the 2 plans. The one just charges you 8 cents per page. So I'm going to say 0.08 per page. And I want to know when that is going to equal the other plan, which the other plan was we spent $7.50, so it was $7.50. So we spend that money up front, but now we get charged 5 cents per page. Okay? And so that's it. It's really just almost like we're setting up 2 equations on each side of the equal sign. The first equation was 8 cents per page. The second equation was $7.50 plus 5 cents per page. And so we want to know, well, how many pages are we looking at to justify when we'll have to buy this plan or when we should buy the plan. And so we just solve this the same way we normally would. Again, get the variables on the same side first. So I'm going to get these p-values together. And then divide. Always running out of space. And so when we look at this, let's see. It's 250 pages. So if you're doing less than 250 pages, it's probably not worth buying the discount card. You just pay 8 cents per page, and it'll be cheaper, okay? And that's kind of the point of this thing. If you have more than 250 pages, that's when the 2 are equal. So if you had 300 pages to print, you're actually better off paying the $7.50 and then getting the cheaper value per page, okay? If I look at something like this guy, it just says solve for x. So this is a literal equation. I want to get x by itself. And so think about what's happening to x. It's x times s and then plus a. That is what's happening. And so if I work backwards through that process, I have to undo adding the a first. So I'm going to subtract a from each side, which over here, those cancel. So I'm left with a negative q. And now to undo multiplying by s, I divide each side by s. I wrote an 8 like a crazy person. And again, I can't simplify this any further. I don't know what q and s are, so I just leave it as negative q divided by s. And that's it. Okay?